Okay, so today what I'd like to do is I'd like to take you through an example problem on this topic called limiting reactant. So you had a chance to sort of practice it and kind of look at what that concept means, and now let's just talk about how you apply that to an actual stoichiometry problem or a lab situation. So the idea here is that imagine you're a chemist and you are mixing together your ingredients and you're trying to predict how much product you can make. Well, you don't automatically know what of your ingredients or your beginning chemicals, your reactants, are going to run out first. But what we know is that when one of them runs out first, that is our limiting reactant, and then that stops the reaction. You can't continue making product if you're out of one of your ingredients. Just like you can't keep making sandwiches if you're out of bread, that kind of idea. So what we're going to do today is we're going to look at a problem, an example problem. How do you go about this in terms of calculations? So here is our example problem we're going to try. So here's my chemical reaction. So as a chemist, I take some zinc, I mix it with hydrochloric acid, that produces zinc chloride and hydrogen. So what I'm trying to figure out is, and more specifically, I start with 130 grams of zinc. I react it with 35 grams of HCl, hydrochloric acid. And the question is, well, what's the maximum number of grams of hydrogen gas that can be produced? Well, how do we deal with this? Well, we have to do two stoichiometry problems, and then we're going to compare those two answers we get, and then that's going to determine what is our limiting reactant and what is our in excess reactant. So if it's a stoichiometry problem, because I'm starting with one chemical and it's asking about a completely different chemical, that means that I need to eventually get to the switchover step, which means that I will need the mole ratios. So remember, that means we need a balanced equation. So let's take a look at this. I've got 1ZN, that's fine. 2 CLs on this side, so I can fix that by putting a 2 here. So then that makes 2 CLs, 2 H's, and 2 H's. So now I've got my balanced equation. At this point, then, I'm ready to start with one of my numbers. I've got two numbers. Doesn't matter which one we start with. Let's start with the one that's first here. So I'm going to start with my 130 grams of zinc. Now remember that the whole point of the problem is to answer this question. What is the maximum number of grams of hydrogen? Okay, so I'm at grams of zinc. I need to get to grams of hydrogen. I can't go right from grams to grams, but I can go from moles to moles, which means I need to get grams of zinc into moles of zinc. Well, I can do that by using molar mass. I check out my periodic table, zinc, oh, here it is, 65.39. That's the number of grams for every 1 mole of zinc. So I fill that in my problem here so that I end up with, okay, I need grams to cancel. So what did I say it was? 65.39 grams of zinc goes on the bottom, and that's for every 1 mole of zinc. I needed grams on the bottom because that's in the opposite spot where it started, so then they will cancel. I'm at moles of zinc now. This is a stoichiometry problem. I got it into moles so that I could do the mole switchover step. Remember, the mole switchover step comes from your balanced equation, looking at these coefficients. So I know that moles of zinc needs to cancel, so I need it in the opposite spot. The problem is asking about hydrogen, so that's how I know what chemical to switch over to, zinc to hydrogen. But I can only do that when I'm in moles to moles. I look at the balanced equation. It is a 1-to-1 ratio, so I can fill in these blanks by just putting 1s here. I know it doesn't change the math, but I needed to do it so that I can get from moles of zinc to moles of hydrogen. Well, I don't want to stop at moles of hydrogen because the problem was asking for grams of hydrogen. So I'm going to do one more problem, or one more step, where I convert from moles of hydrogen to grams of hydrogen. Well, I can do that looking at my molar mass. It is H2, so it's 1.01 times 2, or 1.01 plus 1.01 to represent H2. It's always, by definition, 1 mole for molar mass, and then it's going to be 2.02 grams of hydrogen. Moles of H2 goes away. I'm at grams of hydrogen, which is what the problem was asking for, so I'm ready for my equal sign. So to solve, I will multiply everything on the top, divide everything on the bottom. So let's take a look at that. So 130 times 1 times 1 times 2.02. All right, and then divided by on the bottom, 65.39 divided by 1 divided by 1. I end up with this as my answer. 4.02 grams of hydrogen. Now, just to clarify, this would be my maximum number of grams of hydrogen produced if I use up all of my zinc. But remember, at this point, we don't know if we're using up all of our zinc or if we're using up all of our HCl. So we need to do our second stoich problem, and then we're going to compare the answers to decide that. So we're going to do all the same steps. This gives us a chance to review this one more time, only we're going to start with this number. So I'm going to start with 35 grams of HCl. But once again, I'm trying to eventually get to grams of hydrogen, so I need to get to the mole switchover step, which means I need to turn grams into moles, but this time of HCl. So checking out the periodic table, H is 1.01, Cl is 35.45, so I add those two together, it's just one of each. So 35.45 plus 1.01 ends up being, so according to our math here, so that ends up being 36.4, sorry. Oh yeah, that's right, 36.46 grams of HCl. The definition for molar mass is always 1 mole. So then that's 1 mole of HCl on the top. Grams of HCl goes away, which is good. Now I'm left with moles of HCl, but I didn't want moles of HCl. The whole purpose was to do the switchover step, to get from moles of HCl to moles of hydrogen so that I could answer the question. So I take a look back at my problem here, and I end up looking at my balanced equation. So I end up with 2 moles of HCl for every 1 mole of H2. So on the bottom, I need HCl to cancel. So this is going to be moles of HCl. This is going to be moles of H2. For the balanced equation, I know that this is a 1 and this is a 2. Moles of HCl goes away, which is good. Now that I'm at moles of H2, I can do my last step, my molar mass of hydrogen, just like before. Doesn't change, 2.02 grams of hydrogen because it's H2 for every 1 mole of hydrogen. Moles of hydrogen goes away, which is good because I'm trying to compare it to grams of H2 to answer the question, maximum number of grams of hydrogen gas, and then I also want to be able to compare it to this answer. All right, so I'm ready for my equal sign because I'm where the problem asks for. I multiply everything on the top, divide anything on the bottom. So I take 35, let's clear this out. 35 times 1 times 1 times 2.02 divided by on the bottom 36.46, and then divided by 2 divided by 1, I end up with 0.970, we'll say, grams of hydrogen. So what this means, okay, so we did our 2 stoichiometry problems. What we got to figure out is, okay, I have 2 answers. How do I know which is the right one? Well, the idea here is that you will always choose the possible answer is the one that is smaller, all right? So what we're going to do is we're going to circle this and say this is the amount of hydrogen we should be making. If everything goes perfectly, this is the maximum amount of hydrogen that I can possibly make. All right, so which is the possible answer? It's the smaller one. And how do we know that? Because you ran out of HCl. All right, so let me explain what I mean by that. We choose the smaller number because when I reached this much hydrogen, I ran out of my 35 grams of HCl. So I'm done at that point. All right, and that's important because that tells you that HCl is our LR, meaning that zinc is our thing that is called in excess. We've got a whole bunch of extra zinc left over, but it doesn't matter because we're out of HCl, so the reaction stops at this point. So I don't make any more grams of hydrogen. I never made this. This was never possible. This is a bogus answer, never going to happen. So we did 2 problems. We take the smaller answer because at this point we ran out of something. It's like the sandwich example. If you run out of bread, you have to stop making sandwiches, even if you have a whole bunch of extra peanut butter. You're not going to make a peanut butter sandwich out of just peanut butter. Well, in this idea, you're not going to make zinc, chloride, and hydrogen if you don't have any hydrochloric acid. That's the idea. So that concept is limiting reactant. So this is how you would solve your problem. So the answer to what is the maximum number of grams of hydrogen gas that can be produced? 0.970 grams of hydrogen, based on the fact that HCl was our LR. When we ran out of it, the reaction stopped, so this is our answer. That's it. That's LR calculations. Thanks for listening.